Welcome to our NPTEL lectures on power quality improvement technique. Today we are going to discuss about the hybrid active filter. We have discussed about the passive filter, we have discussed about the active filter, and thus we have seen some topological configuration related to the hybrid filter, but we want a thorough discussions on it. Essentially these discussions will be related to the shunt part of the circuit, the UPQC part of it with the shunt can have this kind of hybrid filtering, and thus after all we require to reduce the overall costs of the system and the better performance. These both can be achieved with the help of this active and the passive filter. So, the presentation layout will be today on the introduction. Thereafter, we shall see that what are the different kind of hybrid shunt active power filter, and thereafter we will see I have discussed one topology in a continuation of the shunt active power filter, while sharing the topological variations of the hybrid filter. We can have the so many topologies there, we shall discuss in detail. Then hybrid shunt active power filter performance rather we will discuss. Thereafter, we will discuss the design of the hybrid shunt active power filter and some newly reported topology we can also discuss and conclude our discussions on the hybrid shunt active power filter. As we know that power quality problem mitigation by using the passive filters and active power filter has been already we have discussed. We know the problem of the passive filters in detail. We have discussed demerits of the fixed compensations, the little bit of change in the frequency, it cannot act properly. Thereafter, large and the bulky size of the mostly the capacitor and the high cost of the inductor, resonance with the power supply and also adjustable speed drive can put to the particular resonance. Then these are the many demerits that we have discussed, I do not want to repeat it, and for this reason we have these demerits of the shunt passive filter. Same way the active filter sometime it very close to the load, and thus if you want to have sometime the reactive power compensations has to be done by this active power filter, and if at the low power factor then rating becomes higher and thus the solution become costly. For this reason the costly solutions and the bulky and other demerits can be removed by giving the marriage together or coupled together. Thus, the higher rating active power filter and the cost consideration, the acceptability of this active power filter practical situations is facing difficulty. So, one of the demerits of the active power filter is a higher establishment costs, because you require to put it, it is not much in the distribution network. If you want to put into the transmission network, then due to the high cost of the device will come because of the higher device rating. But gradually this is all coming down, and thus whatever you have optimized, if you are taking a paper of 10 years old and whatever the cost you are putting there, and if you are doing this analysis today, so that will be totally a misnomer. It will be a totally misguided directions. Cost of the copper and the inductor, copper goes up, thus inductor goes up, but cost of the silicon devices is coming down. So, gradually we may see we may totally go for the active solution only, but here till now we have a gray way, and since we already using the passive filter and thus we require to retrofit some time with that, and thus we require to understand the feasibility of putting a hybrid filter. For this reason, to overcome the costs of the series hybrid power filter, a series hybrid power filter is evolved and extensively used in practice as a cost effective solutions for the compensation of the nonlinear load. So, you have a fifth harmonic, seventh harmonic voltages and you can do this series compensation. The rating of the active filter is reduced by adding the passive filter to form the hybrid filter, which reduces the overall costs, and in many instances they provide the better compensation in either passive or active filter. Why? Because you please understand it. Let us go back to the whiteboard. So, let us take a DQ solution. So, you have a ABC to DQ and ultimately you have D component and the Q component, you have put a low pass filter, and from there you are estimating the it may be the ID and it has ID delta, ultimately you got the ID bar, okay, and that you subtract with the ID delta. Once we get the ID delta, essentially how accurate it would be, it depends on the cutoff frequency of this low pass filter. You can put since you know that this will be a DC component ID bar, you can put this cutoff frequency very low. But problem lies, this will, if you put the cutoff frequency of 10 hertz, there will be some component of ID delta, it is not accurately calculated. You may choose 1 hertz, then you get more accurate result. You choose 0.1 hertz, you get more accurate results. But problem is that if you choose 0.1 hertz, then what will happen? Then you require, once the load change occurs, to get the steady state value, wait for the 3-4 cycles. But what happens if you have a combination of the active and passive filters? Then you can put this low pass filter at a very low value, because initially some dominant harmonic will be mitigated with the help of the passive filter, and thus your dynamic response also better, and you ultimately your steady state THD also will be better. This is the reasons we want to use both passive and the active filter. So, I have cleared this why putting them together will act better. So, rating of the active filter reduces, that is one of the reasons, because it is not burdened with the reactive power maybe, and also the not burdened with the dominating harmonic. By adding the passive filters from the hybrid filter, which reduces the overall cost, and the many instances, and this is the instance I talked about right now, they provide better compensation than the individual active and the passive filter. The hybrid power filters are classified based on the number of elements in the topology. Supplies and thereafter it can be based on the supply system, it can be based on the types of the converter, whether it is a multi-level or the 2-level, or you can have a different kind of cascade topology in between, whether it is even in the multi-level, it is diode clamp or the capacitor clamp or the H-bridge cascade multi-level inverter. So, these are few variant of the topology can also come into the picture. I will discuss in detail about some topological development with the hybrid filter. The supply system can be single phase as it is same for the shunt active power filter, there is not much difference, or the 3 phase 3 wire or 4 wire system varied with the system fit a variety of the nonlinear loads. The converter can be voltage source converter, that is VSC, or a current source converter CSC to realize the active power filter. The number of elements in the topology can be 2, 3 or more, which may be either active filters or the passive filters. You see that this is the overall classifications, and this hybrid power filter can be classified based on the number of elements in the topology, as I discussed earlier, supply system and the types of converter. So, it can be single phase, and then you can have a single phase passive. So, this is no longer than a power filter. You can have that passive active combination, this is essentially the hybrid entity, and also you can have a active. So, I will show you how does it differ. Same way in 3 phase you have a same kind of thing, that is passive, active, passive, and also it is for the 3 phase 4 wire system. So, let us see that the hybrid filter is a combination of the passive filter and the passive shunt filter. So, then it is called the passive filter. So, you have this one, it is a passive series filter, and this one is your passive shunt filter. So, this combination we also call it is a hybrid, but it is no longer a power filter though, but it is this combination is called passive filter. Same way, this is the hybrid filter as a combination of the passive shunt and the passive series, then that is also possible. And you see that there is a combinational variation. You have first series passive, then the shunt passive. Here you have first shunt passive, if you see from the source side, then you have a series passive. So, for this reason this kind of topology is said to be the hybrid power filter. Hybrid filter is a combination of the passive series and the passive shunt filter, and this type of topology is considered as a hybrid filter, as a combination of the passive shunt and the passive series filter. Same way, in this case we can have T network. Okay, so we have discussed in detail of it, but we will later replace one of it. I just revisiting it because for the sake of your understanding only, some part of it, because this is a T network with the passive, and some portion will be ultimately replaced by the active filter. So, this is a 2 passive series filter and 1 shunt passive filter, and here it is, we call it is a pi network, where you have 2 passive shunt and 1 passive series network, and this is also called the hybrid filter as a combination of the passive shunt and passive series and the passive shunt. This is called generally the pi network, and this is generally called the T network. Now, in between you will replace something. So, here this is the impedance of the source impedance that has been coupled or lumped for the short transmission line, and thus thereafter you have PF SS, that is series, and now you have a active compensation of the series, and this is called a hybrid filter as a combination of the series connection of the passive filters and active series filter. Again, you can modify a little bit. So, here this passive filters is connected in series with the active filter, and here this passive filter is connected with the parallel path of this active series filter. So, we require to see that which solutions sees the lower rating, lower power rating, because once it depends on the voltage level. See, in this combination, generally the rating of these devices is the series between V1 and V2, potential difference between these two entities. But it sees the total current to be flown. Here in this case, it branch out the current, thus it does not see the total voltage, but whatever the voltage injection done by the series active filter, that voltage stress will come across it. So, we require to see that which topology has a greater merits, considering that the different values, this is current is going through it. So, you have I into Z is the voltage developed across it. So, what is the rating and what is the rating here, the which one is less, based on that, and what is the performance of it, that is also a consideration. So, we have to have a optimization based on this. Similarly, we can have a shunt series combinations. So, you have a shunt passive filter and series active filter. A hybrid filter is a combination of the passive shunt and the active series combinations, and this combination just reverse. You have a active shunt and the passive series. So, the hybrid filter combination of the active shunt and the passive series. Here you have a shunt active power filter and you have a series passive power filter. So, and this is also a combination. So, all the permutation combinations are possibles, and based on the rating, and it is, we cannot give a unique solution. We have to observe the rating of it, and from there you require to find the optimal solution. Same way, the hybrid power filter topologies, we can have this shunt parallel, there is another shunt. So, what happened here? So, this will acts in the picture little later, maybe that is what I was trying to discuss in the whiteboard, and thus makes the TIST in the steady state quite acceptable value, and initially it will act and mitigate the harmonic, and the fine tuning can be done by this active power filter, and thus rating also will be less, and you get a proper solution, better solution than individual shunt active at the passive filters. So, this is called the hybrid filter as a combination of active shunt and the passive shunt. The hybrid filter as a combination of series connected passive shunt and the active shunt filter. So, now what you can do, you can have this passive shunt, it was connected parallel to it, and here you connect, here you connect in series to it. This is the topology I have shown you while discussing a one topological aspect, discussing the shunt active power filter. And then I decided to have a, let us have a thorough discussion on it, and this is with the nonlinear load. Now, you have a Siemens and you can have a series passive filter and shunt active filter, they are connecting like this. This topology is said to be the hybrid filter as a combination of the passive series and the active shunt filter. Similarly, this one is a active series and the passive shunt. This hybrid filter is a combination of the active series and the passive shunt. So, there is all the permutation and combinations is possible here. Now, let us see that again in the T network you can add one series passive filter. Sorry, it is not a T network, this is a source impedance and you have a combinations of the active and passive, and you put the shunt first, then after series entity, and here difference is that here put the series parts, then only you put the shunt. What happens generally, since it will block certain amount of the harmonic, so its rating required is reduced, and here it will see the overall rating, but what happened generally this performance is superior, because what happened, you got a harmonic content IH, you have a drain for the IH here and it will be blocked here and thus you pass it to the drain. What happened here? Here you first blocked IH, then you have a drain. So, the harmonic content that handles this passive filter will be low, here will be high, but problem lies here, you know, the solutions what you get is inferior than this at the cost of the higher power rating, because you have to design that harmonic current, more harmonic current will sink to it, higher power rating here, and here it will see the less, but voltage level will be almost same, because there will be a drop in the voltage that due to the harmonic voltage that does not have a tangible difference between this point and this point. And thereafter what you do, you put a whatever you are left with, you inject the active filter and clean out this process. Generally, I have taken the observation from this point, since source current is flowing and it will have with the ZS will have the fifth harmonic voltage and the seventh harmonic voltage. And what does it do? You know, it generally reduces the fifth harmonic current, thus the voltage developed here it will be less. Similarly, here it will block that fifth harmonic and the seventh harmonic voltages, and thus the current available here due to the fifth harmonic will be low, and that will be again the shunted to the ground, and ultimately whatever you are left with, the voltage contamination of the fifth and seventh or other harmonic, that will be mitigated by the series filter. Now, let us see the combinations that we have already discussed little bit. So, thereafter first we have a series compensations for the particular filter, then we have a series active filter connected parallel to the another passive series filter. So, this is called a hybrid filter as a combinations of the passive series filter in series with a parallel connected active series. So, if I tell these things you will confuse, by understanding the topology you will understand better. And ultimately once you put this entity here, this becomes the hybrid filter as a combination of the passive shunt, this one, and the parallelly connected active series and this shunt combinations with the nonlinear load. Now, similarly you can have a shunt solution. You have, this is your series passive filter and you have a active shunt solution, and that is also possible for the current harmonic mitigations. And hybrid filter as a combinations of the passive series and the active shunt and the passive series combination has been shown, and thereafter you have hybrid filter as a combinations of the parallel connected passive shunt with active shunt and the passive series has been shown. So, this is something you can see that this entity here it will be shunted. So, you have both the shunt and one series has been left. Here more importance is given for the series compensation, and here more importance is given for the shunt compensation. That depends on essentially your source inductance. If your source inductance is less, then fifth harmonic voltage and seventh harmonic voltage all will be low, and you generally but you may have a good quantity of the fifth and the seventh harmonic current, then you go for this solution. Once you find that fifth and seventh harmonic is quite high because of the high source inductance, then we may go for this combination. And thus, this is also a possible features, that is your ZS, thereafter just fast it will have the active series, that will mitigate all the, it is better because the source of the voltage harmonic is the source inductance due to the nonlinear load, and thus you mitigate all the harmonics related to the which is coming due to the source inductance. Then this entity will have to sink the current, since your fifth harmonic current is less, it does not have a problem, voltage is less, it does not have a much amount of this current left, and also whatever it is been left out, it will be blocked. And if you see from this side, so if you see from this side, this will be blocked, and whatever it is there, it will be sink into this passive filter. Same combination when you are looking for the, when your source inductance is quite less and you do not have much problem with the voltage, harmonic voltage fifth and seventh is quite less, then you go for the solutions. You inject the fifth and seventh harmonic, ultimately sank, the direction is such that, so that whatever the nonlinear load it is having, so it will be transformed, and there is a small amount of this voltage harmonic that may be there, that can be suppressed by this series filter. Thank you for your attention. I shall continue to our discussion with the hybrid filter topology also in the next class.